Okay, we're going to look at just one kind of tricky radius of convergence problem. It looks kind of intimidating, but it's not that bad. I just want to show you this one. So this one is a series, a power series made up of, okay, this is our sequence formula times x to the n. And what this sequence is telling us to do is take the numbers 2 times 4 times 6 times 8. So multiply this string of numbers ending at 2 times n, whatever n is. And then the denominator is 3 times 8 times 13. Notice we're skipping by 5. And so a formula for that sequence of numbers multiplied would be 5n. Remember, if it's changing by 5, then it's going to be 5n. If n is 1, we're supposed to be seeing 3. So 5 times 1, I would have to subtract 2 to generate those numbers. So just to get a feel for this, how this series would look. So the first term, oh, and then we're squaring it too, yeah. The first term when n is 1 would just give you the 2 and the 3 squared times x to the first. When n is 2, you would do 2 times 4, 3 times 8, square that, and then times x squared. The next one would be 2 times 4 times 6, 3 times 8 times 13, squared times x cubed, and so forth. So you see how this works. What this formula is telling you to do is each formula is telling you to start multiplying and end based on whatever your n value is, okay? So the way we're going to test this one is to use the ratio test, where we take the limit as n goes to infinity. We're going to test for absolute convergence. Now, the way this works for your a sub n plus 1 term, this formula is a sub n, right? That's in the denominator. A sub n plus 1, if you think of it, it's just supposed to be the next term, right? A sub n plus 1 is the next term. So what that would look like, 2, 4, 6, 8, and then you get to 2n, that's a sub n. The next term you would have multiplied by the next multiple of 2 there, right? Which would have been whatever 2n was plus 2. That would have been your next term. Same thing for the denominator, 3, 8, 13, 18, 5n minus 2 would be your nth term. And we know that the next multiplier, I would need to add 5 to this, which would give me 5n plus 3. Okay? And then there's a sub n. The x sub n plus 1 over x sub x to the n power is going to just leave you with x. And you can see if you flip this denominator and multiply it, you get a bunch of stuff canceling out, right? Everything's going to cancel out all the way up to 5n minus 2 here, leave you with 5n plus 3. Same thing with the multiples of 2. So we're really just going to be left with 2n plus 2 over 5n plus 3. Remember, it is squared. That limit, if you take the limit as n goes to infinity, will give you 2/5 by the power of n. We're going to square that. So we get 4/25 x. And by the ratio test, remember to converge, that would have to be less than 1. The absolute value, that would be less than 1. So that means 4/25 x is between -1 and 1. Multiply by the reciprocal, everybody on both sides. And we get that our interval of convergence is between -25 and +25. So the center is 0, and my radius of convergence would just be 25/4. This seems like kind of a strange power series, but we will see later on there is a certain function whose power series has that kind of pattern to it. And when we have to find the radius of convergence, it's going to look very similar to this.